All right, quick review. So if we end up solving a system of equations and we end up with something like 0 equals 17. So both the x and the y are eliminated. So I have 0 on that side, and then I have a number on the other side. Or it should be a number that's not 0. So you ask yourself, when does 0 equal 17? Well, 0 never equals 17. So that's the case where there's no solution. Now, if you do that elimination, or if you go to solve and you end up with 0 equals 0, that's the case where there's infinitely many solutions. Okay? That means that when does 0 equal 0? Always. That means those are always going to be the same. They're the same line. When I add two things that are the same together, I make them opposites and add them together, I get 0. They cancel each other out, right? On both sides. So, next example. Find the values for R, S, and T that produce a no solution. So I want the no solution case is when we end up with 0 equals something that's not 0, some number that's not 0. Okay? Okay, so what we're going to do is we're going to figure out, well, for that to be the case, when I add those together, that means R, I'd have to have negative 2x plus 2x. I'd have to have plus 5y, and I'd have to have S be plus negative 5y. And this equals 12. So T could be anything except for negative 12. So it means R is 2, S equals negative 5, and T could be anything except for negative 12. So any number except for negative 12. Now, for it to be infinitely many solutions, the only difference is I have to get 0 equals 0. So R and S are going to stay the same. But now T has to be negative 12 to make it 0. So that's B. This was A. So R and S have to be certain numbers. For A, T can be anything but negative 12. For B, R and S and T all have to be specific numbers. All right, to do our word problems, what we're going to do is create systems. We are going to use the relationships that they give us. So things that we're going to look for are totals, total ticket sales, total dollars, things like that. Okay? Or how they're related. If they say that they sold twice as many of these as those. Okay, that gives you a relationship. That's going to give you an equation for them. Okay, so you set up your equations based off what you're given. So at a high school basketball game, student tickets cost $2, adult tickets cost $5. Total ticket sales earned. So this is a total dollar amount. So that's going to allow me to find one equation. Okay, then the other one I'm going to do is going to be the 500. The 500 is the total tickets sold. So there's my two equations I'm going to have. I'm going to write one for total dollars. So the total dollars are 1,525. Well, to figure out how much it costs to go to a game, you need to take how many students you have and multiply those by $2 because they're $2 each. So to find out how much total you made on student tickets, it'd be $2 per student times the number of student tickets. Plus, now you can do the same thing for adults. It's $5 per adult ticket, so you take the $5 and multiply it by how many adult tickets you sold, and that's going to give you the total amount that you made. $2 for all the student tickets we sold plus the $5 for each adult ticket times the number of adult tickets. And we add those together, and that tells us our total dollars. Now, the total tickets sold, well, this is just made up of two things. So the total tickets, well, all you do is to find out how many total tickets were sold. There's 500 tickets. Well, that's made up of the adult tickets. Well, let's keep it in the same order. Student tickets plus the adult tickets. So there's my two equations. So now in this case, when I look at this, the easiest way to solve this would probably be to use elimination method. So I'm going to take this and multiply by -2, so that when I do that, this equation becomes -2s minus 2a equals -1000. So now I can add those together. So the s's are eliminated. So I end up with 3a equals 525. So now we divide. Okay, so let's see, 3 goes into 5 once, 2 left. 3 goes into 22 7 times with 1 left. 15, 3 goes into 15 5 times. So there's 175 adult tickets sold. Now I need to find the number of student tickets sold. So the student plus the adults have to add up to 500. So take the 175 away from the 500 to find out how many student tickets. So there's 325 student tickets sold and 175 adult tickets sold. Okay, the other types of equations you might get. So that's where they gave us totals for each. So another type, if they say the number of cars is 13 more than the number of vans. You have to be careful with these. Okay, so the cars is 13 more than the number of vans. Whenever you see this, is equals. So cars equals 13 more than means I have to take the vans and add 13. So to find the number of cars, I got to add 13 to the vans. So that would be an equation if I had something like that. If they say double, okay, the number of cats is twice the number of dogs. So to get the number of cats, you got to take the number of dogs and multiply by 2. Because the is here. So that's whatever you have is, put the equal sign. Cats equals 2 times d. So now when you get that, think about it. So to get the number of cats, I got to take the dogs and multiply by 2. That would be, the number of cats would be twice the number of dogs. Okay, those are the types of relationships. If they have less than, you would be using subtraction. Okay, so that's another type of equation you might get. All right, so we talked about what R, S, and T would have to be to make certain situations. And we did a modeling problem where you had to set up a system and then solve it.